Hello everyone, myself Pawan, and you all are welcome in the lecture number 4 of the ML series. And in the previous video, we have seen the regression model in the machine learning. And in this video, I'll try to understand the overview of the classification model those are used in the machine learning. Before I start my presentation, as in my previous video, I also mentioned the machine learning life cycle, and suppose we have a problem of the classify problem. Our first motive to identify the what is the problem, then we have to need the specified data for that problem, then we have the data collection part, then we have to be analyze the ED of the data of each and every features. We try to be understand the about the ED process, and then we have the feature engineering. In this we try to remove all the data pre-processing part, we remove all the missing value and the scaling of the data and number of parameters we are used for the scaling of this. Then we have the model training part. We are trained before design the model. We are divide the data in two parts, in train part and the testing part. Then we have the model selection. Then finally we have to find the accuracy of the model. This is the general overview of the life cycle of the machine learning. In every problem we use this same process of the MLC cycle. Then we first step the feature engineering. As in last video I also mentioned, before to design the model, we have to the first pre-process the data, and first we have to use the feature transformation. In this we try to remove all the missing value, and then previous video we also discussed how to remove the all missing value. Then we have the data encoding. Then we have the remover of all the outlier. How can remove the outlier from the data set. Then we have the feature scaling, and the last we have the very important is the feature selection process, right? And as we see in our last video, in the supervised machine learning, there are two types of the problem we are called. Either we have the problem is the classify problem, in which our output target value in the some division of the category we are divided into binary or multiple class. In the regression, we have the output is a numeric value, right? And the supervised model, as we mentioned, a model in which we have the input and data value are given in a data set. We are called the supervised data. And also we can say the data which in the label form we are called apply the supervised learning here. So in last video we have seen the regression problem. In this video we try to be understand about the overview of the classification problem, how they help to solve the problem, right? As we see in the last video also, this is the diagram in which we have the 12th number, then the final number and the placement. Here the placement is the output feature. This is the classify problem. On the basis of this input, suppose we have the input 12th number and this number. With the help of this input variable, we try to classify the data, the output feature, either placement yes or no, right? It is a classification problem. And the regression problem, what we happen? Let's suppose we have to find out the percentage of the student. Let's suppose we are enter as an input in the number of the 10th and 12th number. And with the model, we try to identify what is the probability to get the answer in the B.Tech number, right? So this is the output feature, the output data in the form of the numeric value. In this, the output feature in the form of the some division, yes, no, in the two classes, yes, no, or sometime maybe the multiple class, depend upon the data set, right? So in this problem, classify problem, what we do? We try to classify the data on the basis of the input value, either in the binary form or in the multiple form. It depends upon the data value, right? As mentioned, the classification, this is a supervised machine learning algorithms, and that is used to identify the new observation on the basis of the trained data, and then classify this value in the two classes, if it is the binary classes, right? The class may be sometime represent the yes, no, and the 0, 1, and also we can use the image also. We can give the input to the model, and we identify or classify the image, either the two types of image. But we have to be focused one thing when we classify the number data in the generally. So what we do? We try to change all the numbers. So let's suppose we have the output feature in the yes, no. In the previous video we have seen we have to first change the output feature yes, no in the binary form. So if the output feature is the yes, no form, so first we have to change the form of the numeric value with the help of the one-hot encoding. We also mentioned in the video number 2. If you are not aware, you can go for the previous video and check. In video number 2, we give the overview of the encoding process, right? So in classify, generally we use to classify the input feature either in the class A and the B, or in case of binary value. In case of the multiple class, we divide into either number of this. Let's suppose we have the temperature. Temperature is the medium, high and low. So we have the multi-class of the data. It depends upon the data set value, right? And as we mentioned, we have the two types of classification algorithm we use. Either the binary classify. If the classification problem has the only two possible outcome, we are called the binary classify. Example, yes, no, male, female. And the spam, the email are the spam or not spam. They are the binary types of classify. In the multi-class, if the classification problem has the more than two outcomes, we are called the multiple class. For example, with the temperature high, medium or low. We are enter the temperature as an input. With the model, we try to identify either temperature is the high, medium or low. So model will predict the answer in the multi-class, right? And sometimes we have the different form of this also mentioned. So these are the two types of generally model we use in the to classify the problem as a output feature, either binary classifier and the multiple, right? Then we have the some most popular algorithm used for the classification of the logistic regression is the one of the most it is the first model of the we can say the for the classification problem. Then we have the SBM model, we have the decision tree and the random forest and the KNN. They are the most popular algorithm used for to classify the value either in the binary form or the multiple classify form, right? So we just simply see the overview of this algorithm. We are not detailed discussion of this algorithm. In the next video, try to take every algorithm one by one and we try to use with the help of some example. And now if we first move on the logistic regression. So logistic is the regression that output of the value either in the binary form or multiple form. So what happens in this, if you see, this is the model, the output is the predict the output of the dependent variable. Therefore, the output must be in the discrete value, right? Either in the yes, no, 0, 1 or true, false. But instead of giving the exact value of the 0, 1, this model gives the probabilistic value which is lie between the 0 and 1. Means, let's suppose we provide some input to the model and we want to predict the answer either the value is the yes or no. But this model gives the answer in terms of the probability value in between 0 and 1. So, suppose we have the threshold value is the 0.5. So, all the value, output value, those are the value, answer, the more than the threshold value, we classify in the class A. Let's suppose the value is the less than threshold value. What we do? We try to be put in the class B. So, as mentioned in the diagram, we have the threshold value. They said the threshold value is the 0.5 and all the value, those the output feature value is more than 0.5. We are classifying class A and the output feature value less than threshold value. Let's suppose the output value is 0.3. So, in class number 0. So, we have the two class, either class A, 1 and class 0. So, what happened in this? This model is not classify the output feature in class 1 and 0. They classify the value on the basis of the output value. If the output value more than threshold value, they put them in class A and if the value less than threshold, put the value in the class 0. So, they are mentioned that they give the probabilistic value which lie between the 0 and the 1. So, they are used the segment function as so in the form of this. So, with the help of this, they try to classify the value either in class A and the B, right. So, just simply give the overview of this. In the next video, try to take this again this algorithm and the detailed description of that, right. Then we have the two types of the logistic regression. Same, we have the mostly we use the three types of this. First is the binomial. In the binomial logistic regression, suppose we can divide only two possible types of the dependent variable, either such as the 0 and the 1, sometime pass and fail. So, we have to classify the data in the binary form and we have the sometime we are called the 0 and 1 answer and sometime we have the pass or fail, male, female. So, they are the binomial types of logistic regression. In the multinomial, as we mentioned in the before only, there is a more than 3 value. Suppose we have the 3 possible outcome. Temperature, medium, high, low and with 3 types of image also. So, they are classify the number of image in 3 types depend upon the dependent variable size. Dependent variable in the case of image depend upon the image, right. Same other we also use the ordinal types of this. In this case, suppose we have the order of the output feature in the order. We have the temperature low, medium, high. So, we classify the generally model in 2 types, either in the binomial and the multinomial. In multinomial, we have the 2 cases. Sometimes we have the output feature in the order form. We are sometimes called the ordinal encoding, right? And sometimes they are not in the order, we define the multinomial. So, this model also work on the both problem, either we have the binomial problems and the multinomial problem, right? Then we have the SBM model. SBM model is the very well famous model of the classification algorithm because in SBM model, if the size of data is not more and the SBM perform very well. if you are compare the both the model, Logistic and SBM, it is my personal opinion for all of you, try to use the SBM model. Because in case of the Logistic model, they are not give the proper answer. The valued answer of the depend upon the value of the threshold value. Let's suppose the answer is the, suppose the output is the threshold value 0.5 and output is the 0.51. So only value of the 0.51 they give the answer, classify the value in the class A, right? And suppose output is the 95%. Threshold value is the 0.5. Then either they are classified into the form of the one class. So is it, if you are compare the both the output result 0.51 and 0.95, it's a very big difference. But on the basis of this threshold value, they classify the answer either class A and the class B. So if we use the SBM model, SBM is the very good model for the low class data set. So what happened in this? They tried to design one decision line. With the help of this decision line, sometimes we are called the optimal hyperplane, they divide the data point into two classes. Either we have class A and class B, or sometimes class 1 and 2. So what happened in this? We have to draw a decision line. This is the optimal hyperplane path which divide all the data point into two parts. Let's suppose we have some data points here and this one. So how this process is designed? So our main motive to design the best decision line. This is the main motive of this algorithm. What happened? They try to take some data point. Those are near. Suppose this is the, they assume this is a decision line. So they try to find out the data point. Those are very near of this, and the same in the this side near of this. They try to use the margin of this. So they are called the margin point. So they are draw a line, which is the draw a margin line, which is those points are very near to the decision line. So the main aim of this model to try to maximize the margin distance. So with the help of this model, with the help of this optimal path, they are classify the output feature either class A and the class B, and all depend upon this optimal decision line, right? Then we have the also two types of problem solved by the SBM. Sometimes data is the linear separable and sometimes data is the non-separable. So SBM is the model who perform better in both cases. Either data is the separable form. Let's suppose we have the data in the separable form. Like this, we are defining this. They are the data. These are, and this is the data. We want to classify into with the help of decision line, two line. Either they are in the class 1 and 2. So this data is separable data. Sometimes data is not unseparable. So suppose we have this plus, we have the multiply, then we have the plus, then we have the plus, then we have the multiply, then we have the plus. So this is the unseparable data point. So what happens in this? If the data is the unseparable and we are called the non-linear data, so SBM perform both of them. So they mentioned in the PPT, linear SBM is used for the linear separable data, which means the data is classified easily into two classes by using a single state decision line. This one. So such term is termed as the linear separable data, and classifier used called as the linear SBM classifier. So with the help of the linear SBM classifier, we have classified the data point with the help of the decision line in two parts, either in class A and the class B. The non-linear SBM model. The non-linear SBM model is used for the non-linear separable data. Sometimes data is not the separate, it is the non-linear data. So which means the data set cannot be classified by using a straight decision line. If you draw a decision line, this one, so this line is not separately divide the both data in class A and B, because some point of the plus here, some point are the multiply, some are the multiply and the plus point. So it is not possible for us to, with the help of this decision boundary line, to classify all the data into two classes. So we are called the non-separable data. So then we are used the non-linear SBM model. So non-linear SBM classifier are used to classify the data when data is the non-separable, and with SBM used in this to solve this, they are used the SBM kernel for this. So SBM kernel is the approach they are used for to solve the problem or the non-separable data set, right? We are define the next video about the SBM kernel also, right? Then we have the k-nearest model, and the KNN is the third model. It is very also used for the small data set. And what happened? These algorithms assume the similarity between the new classes. Let's suppose we have the data is divided into two parts, A and B, and new data point entering to the, we have to classify the new data point. So what happened? On the basis of the similarity of the data point, they either enter into class A and the B, right? Let's suppose, as mentioned in the PPT, KNN assume that the similarity between the two new classes data and the already present cases, and put the new case into the that classes most similar to the available class, right? Let's suppose we have the two classes, class A and the B, and the new data point is enter in this. So what happened? This is a new data point. The before KNN model, this is the endpoint. Then what happened? When we apply the KNN model here, what happened? This let's suppose the value of K is the 5. Means it will ask from the 5 points, 5 near point. Let's suppose they ask from this point. They are the 5 near point for this. So with the help of this point, and they are very far point away. So what happened? What is the basic idea of this model? Let's suppose the value of K is the 5. So new data point ask from the 5 data point, those are near to them. Let's suppose 3 points are near to the class A and 2 points near to class B. And they use the distance, equidistant distance they found out. On the basis of the distance, they try to find out the minimum classes. Let's suppose the class A have the 3 data point, they have the minimum distance from this new data point, and class B have the only 2 point distance minimum to this point. So what happened in this? They transfer the value into the class A, right? If what is general basic idea for this, we have to first define the value of the K. Let's suppose we have 5 value we give in this PPT, and those means the new data point ask from the 5 nearby data point, and those data point are minimum distance from the new data point. They classify the data in the same category or same class. So in this PPT, what we see, we have seen that the class A have the maximum data point, those are near to the new data point, and they classify the new data point into with the help of this into this one, class A, right? This is the basic idea of the KNN model. Then we have the decision tree. If the size of data set is large, so we have to prefer the mostly decision tree. So it is a tree structure classified in which the internal node represent the feature of the data set, right? And the branch represent the decision rule, and each leaf node represent the outcome of this. So generally we have the 3 part of this. We have the branch node, and we have the leaf node, internal node, and we have the last one is the leaf node. So leaf node represent the outcome of this. So in decision tree, as we mentioned, in decision tree, there are 2 nodes, which is called the decision node and the leaf node. This is very important. So what happens? The decision node are used to make any decision, and have a multiple branch, whereas the leaf node are the outcome of this decision and do not contain any further branch. So this is the leaf node. Either the output is a 0 or 1. After this leaf node, we are not classify the data, and the decision, let's be the root node, we are give the input feature here, and the input feature are then classified in the form, and the last we reach on the final decision, either they're classified the 0 or the 1 value, right? Now problem in the decision tree, we suppose we have the 5 features. Which features come on the root node? This is very tough for us. So the main motive of this tree to find out out of the given number of feature, we have to keep the one feature on the top root node. After then we move on then divide the other feature on the subtree node and the decision node. So this process repeat up to the last leaf node. Let's suppose we have for example, we have the information of the student. We have to identify the placement of the student. Either student is placed and not. We have the number of the input feature. We have the age of the student, the father mobile number, father name, mother name. So we have, and the number of their engineering number, their 10th number, 12th number. So we have to keep which node, which input feature. First is the root node. This is, and there is some algorithm used for this. They use the entropy for this, and we have the Gini index for that. And with the help of this, we try to find out how can we select the best node as a root node. So we are make a separate video on the decision tree in future, right? Then we have the last one is the random forest. If the size of the data set is very large, and sometimes we use the random forest there. So random forest is a classifier that we have the number of the decision tree, right? So we have divided the data set into number of the decision tree, and it is generally used for large data set. As mentioned in the PPT, we have the trained data 1 on with the help of decision tree, then trained data 2 on the decision tree. So what we happen, we try to divide the data set into number of the decision tree, and on the basis of this, we try to take the average of this sometime. So decision tree 1, 2 and 3. With their Boolean classifier, we take the average of this and finally we are give the output of this. So we have the, what happened this is the greater number of tree in the forest lead to the higher accuracy. Let's suppose we have the, for example, we have the data size is very large and we are increase the number of decision tree. So what happened? We have the number of the option to reach on the every data point. Let's suppose we apply the SVM model here. So what happened? The SVM try to make some distance line, and suppose we have the size of data is very large and this is the number of data set we have here, and we use the distance line for this. So maybe some outlier may be in the present case of the SVM model. So what happened in this? If we use the random forest, they make the number of the decision tree and the size of decision tree is maximum. So what happened? We are reach on the each and every data point, right? With the help of this, at the end, what we do? With the help, we try to use the Boolean classifier. With the help of this, we take the average number of this. On the basis of this average number, we either divide the class either in 0 and the 1. So this is the one of the best model out of this all 5 model. If the size of data is very large, right? So you have to, I prefer or I request all of you to prefer the random forest, and the size of data is not very large, then you try to prefer the SVM model, right? Then we have the, how can we identify the classification matrix? Means, how can we identify the accuracy of the model? After design the model, the last, our objective to find out the accuracy of the model, how our model is performed well, right? In this case, we have the number of the matrix. We have the to identify the performance of the any classification model. We have the first one the confusion matrix. Then we have the AUC ROC curve. We have the precision, recall, F1 score. So first we mostly use the confusion matrix for this. The confusion matrix is the, suppose we have the binary classifier. So we have the 2x2 matrix. If we have the multi-class and the size of, so suppose we have the multi-class, we have the 3x3 input output, 3 output feature. Then we have the 3x3 matrix. Let's suppose the binary, we have the two either 1 class and 0 and 1 and 0. So this is the confusion matrix. With the help of this matrix, we try to find out the accuracy score. So it depends upon the TE, true positive plus true negative, upon the TP plus TN plus FP plus the FN. This is the general calculation formula of the confusion matrix. With the help of this, we try to find out the what is the performance of our model, right? So suddenly we have in the sklearn we have the library. With the help of this, we have to import this library, and we have to pass the value, and the model will generate the confusion matrix of this. So confusion matrix is the one of the performance matrix to identify the performance of any classification model, right? Then we have the other is the precision, recall and the F1. There are also 3 parameters. With the help of this, we also find out the performance of any classification algorithm. One is the recall. So we have the value. The recall is called the true positive rate, right? Or the proportion of the all actual positive that were classified as a positive, which is also called the recall value. So recall is the TP upon the TP plus FN, right? Same we have the precision. Precision is the TP upon TP plus the FP. So all the difference is the FN and the FV. If we are comparing recall and the precision, the difference between the false negative and the false positive value only. So TP is precision is the proportion of all the model positive classified that are actually positive, and those are actually correct positive, right? The difference is the FN plus the FV. Then recall. Recall is the average or combine the both precision and the recall. So its value is the 2 PR upon the P plus R. Here P is the precision, R is the recall, then precision and the recall. Means it is the combine both the feature of the precision and the recall. So we have the one matrix is the confusion matrix. With the help of this, we are evaluate the performance of any classification models. Then we also use the recall and the precision and the F1 score. Also, and third one is the AUC ROC. We are not mentioned in this PPT. So we generally when we design any model, what we do, we try to use the confusion matrix to find out any model performance, then the recall, then precision, then F1, and last one is the AUC ROC. So what we have seen in this video, we have seen we have the problem of the classification problem. Either we have the 2 types of problem. We have the binary problem and the multi-class problem, and we mostly use the 5 algorithm. And the logistic algorithm, we have the SVM model, we have the KNN model, we have the decision tree, and we have the render forest. And the data size is small, so we have to mostly prefer the SVM model, KNN model, and the logistic model. If the size of data set is very large, so we have to prefer the most decent tree and the random forest. And at the last, we performance of the model with the evaluate with the help of the this performance matrix, right? So I hope you understand this video. In the next video, try to take one every model and we see the with the help of the example, we try to use how this model are performed. Thank you very much.